Today I've come out to the garden because I need a little bit more room. I'm really excited because all of the bits have finally arrived for me to assemble my carabiner breaker. So this is going to be a kind of a portable snap tester type thing. I've had kind of variations on this in the past using Hilti Hydrojaws and an enforcer load cell, but both of those are limited to 20 kilonewtons, and that isn't enough to break most carabiners. So I've put together some equipment that can potentially do up to 50 kilonewtons on this one, so should be capable of breaking any kind of hardware. But yeah, this is all portable, so it can come out with me. I can take it to PPE inspector training courses and possibly off to kind of caving gatherings and things like that. And it's just great to be able to finally put it together. So yeah, I'm nursing a possibly broken toe, so apologies if I wince a little bit. But let's get on and get this thing built. So I guess the first thing to talk about is the frame itself, the girder here. This was just a standard U-channel girder. It's got lots of existing holes from kind of previous incarnations and what it was kind of before I turned it into this. What I have done is taken some 20mm thick steel, bored a hole through it. I've welded that to one end permanently. I've got another piece here, and this is to sit kind of in that channel there, or even on the end if I needed to test some longer samples. The reason this one's removable and not welded on, it's just simply so that I can easily kind of dock and remove the load cell without having to kind of hold it in place on a fixed structure. I've added some legs, bits of wood, so this will be kind of tabletops and things like that if I end up taking it inside to do anything with it, and giving it a really good kind of heavy coat of black paint just to, well, style it up a little bit but also protect it from corrosion. Obviously with bits of metalwork and hydraulics and stuff rattling around inside, stuff's going to get chipped, so the first thing that's going to go in is a strip of carpet. So luckily we've just had our whole carpet redone, so we had some offcuts, so I trimmed one down to sit in there perfectly, and that also nicely covers over the bolt heads from where I've bolted down the feet onto it, so nothing's going to get scratched. So that'll deaden the kind of bangs and noises as things break, and obviously protect the kind of expensive bits of kit in here from getting too scratched up. So at this end, this is going to be the kind of hydraulic end, so we've got this bit fixed here, big 20mm hole through there, which took a fair while to drill, I'm sure you imagine, and on that we've got these 6-ton working load limit lifting eyes, so there's a massive safety factor on these, so that'd be 60 kilonewtons anyway, but they'd break far above that, so these are more than strong enough. So this one's going to mount at that end, so we stick that in there. Got that on the back. Put that at an angle just to make it a little bit easier to get the hydraulic hook in there. Nip that up nice and tight. And that's that bit done. The hydraulic ram, well I've got the ram itself plus the pump here. So this is known as a pullback ram. So this is the kind of thing that mechanics and garages would use to pull dents out of vehicles or square up frames. So when you apply hydraulic pressure to this, the ram compresses, it doesn't elongate and push. And this is ideal. So this is rated for 10 tons, that's 100 kilonewtons. It's twice what the rest of the rig will be capable of doing. So again, there's a nice big safety factor on this. The ram with the pump and the hydraulic fluid, well, just, yeah, a couple of £100, but these are serious bits of kit, seriously heavy duty, so nice and safe to use in this kind of setup. The ram fits into that eye that we've just placed there, and then that'll sit down nicely onto the carpet there. That's where the pump's going to attach, but I won't do that now because it kind of gets in the way. The next bit we need to look at is the load cell. So let's say I've got my piece of steel here, the load cell. So unlike kind of climber specific load cells, this is an industrial one. This comes from a company called Load Cell Shop. I've had this one spec'd up to be capable of doing 50 kilonewtons. Its braking strength is another ton above that, so 60 plus kilonewtons. This one comes with an optional USB module. And what that does is it allows it to communicate with a laptop or a computer directly, without the need for any kind of specialist coding. So there's free software that comes with this that will display live readings and a graph and allow me to pull out the data into a spreadsheet to make my own graphs or whatever I want to do. This was definitely the most expensive part of this whole setup. As you can imagine, you're looking at about 500 quid, just under, for all this in here. So yeah, it's all tax deductible. Now the load cell is going to be at the sample end. It's going to be fixed to this steel block. What I've got is another M20 hole, because this is threaded for an M20 nut, and I'm just going to take a bolt, run it through and screw the cell directly in. These are very robust bits of kit, so you don't want to drop them, but this is just a great big machine block of stainless steel. Very, very strong, very, very tough. There we go, and then we'll just give that a little nip to hold it in place. There. So on the frame itself, I have cut out this aperture to take this piece of steel, but I've also had to put another notch in to take the cable as it emerges from the load cell. It would just about fit in without that, but I was worried that just by repeatedly flexing and bending the cable I'd lead to kind of some premature wear on there, and you know, it's expensive enough as it is, so I don't really want to have to send it back for a new cable anytime soon. To attach a sample to this, then I'm just going to need another lifting eye. Again, M20, it's all super heavy duty hardware, and that can just screw straight into the cell itself. No, can't do that all the way up and too tight, because I have to leave clearance within these little holes and make sure they don't interfere. So that's probably about right there. So there's a little bit of free play in that. So what I've actually done is chopped up a little bit of carry mat, and I can pop a layer just under the load cell just to hold it in place and to protect it further from any bits of broken hardware that might ping back. So if something breaks, the force is going to try and take it that way. I will just put in another little wedge there, so nothing's going to get past that and up to the load cell itself. So you can see then we've got our fixed end with the hydraulic pullback ram there, and we've got the load cell in here, and that can be moved to make it slightly longer test bed if needed, but this is more than enough for a carabiner to be broken. So the next thing will be kind of how I attach the sample. So I want as little kind of flying metal work as possible. So what I've opted for are these soft shackles. These come from a marine supply company. These are rated to 10 tons. Again, that's twice what I can possibly put into this system, because I don't want to go above 50 with the load cell anyway. I was concerned a little bit about wear to the soft shackles from like the hook eyes and the various connections, so I've just got some old tubular webbing I've just threaded onto one side here. And when you test carabiners for certification, you're using quite a small diameter, like a 12mm steel pin, and these are kind of significantly fatter than that. So again, I was worried about getting kind of strange results if I'm pulling on something that's far fatter than the test was designed for. So I've bought some 10-ton lifting chain here, again all kind of certified standards, cut a couple of links off and just tucked it into the soft shackle. So that's where the sample's going to attach, actually into the chain links itself. And I've done a few little variations on that. I've got single link, triple links and so on, so if we've got a big variety of different size gear, I can just swap out the chains to fill that gap. So one of these is just going to sit directly onto the ram hook itself, and the other one is going to attach into the lifting eye that's on the load cell. And these are wonderful things. Oh, go back to front. Get that in there. Slip that over. They just kind of noose closed on themselves. Very, very clever, relatively simple bits of kit. But I could of course do that with Mayons or big heavy duty shackles, but again, when things go ping, I want as little metal and weight to be flying around in here as possible. And yeah, that does happen, you know, when these things break, that's going on 20-30 kilonewtons, you know, up to 3 tons or so of force suddenly being released, so stuff will fly around. So what I've also got are some big thick kind of 5mm sheets of acrylic. So I've got a old Snapgate carabiner here. I'm not going to break it yet, I'm just going to show you how the sample kind of sits in. The soft shackles are a little bit of a tight fit, but once they get their first pull they elongate maybe about another kind of quarter of their length on there, so that'll be easier to clip in kind of subsequent samples once they've settled anyway. Now, again, the soft shackles are there just to limit the amount of metal stuff to fly around inside this, but there is still some metal that's going to fly around. So the stuff can come out of here at quite an impressive rate and could potentially cause some injury. So what I need to do is shield the whole setup as well. I don't want anything breaking and flying off into, well, my audience, myself, cameras, or, you know, the load cell, causing any damage. So what I've had made up is some sheets of 5mm thick clear acrylic, which I've just finished cutting out to accept things. So I've got 2 panels for this, one that can be pretty much kind of permanently attached on the hydraulic side of things, and one that's a bit more easily removable for the sample side of things. So we'll just get the protective coating off those. Ooh, that's quite satisfying actually. And then that one's just going to sit down on there. Now obviously they're not going to stay put all on their own, so without anything kind of posher available, I've just opted for some bungee cord loops, which I've tied up so that can slip over there. Give me a bit of a tight fit getting over the legs. So I've got one down this way. So I've got one at either end on this, one there, and another one there. We'll just square that up. I'm not worried about tiny little gaps at the end, nothing's going to make it that far. So now I've got plenty of room to allow me to connect the hydraulic, but if any of those broken bits kind of fly up this way, that's all safe as well. And if for some reason I set up the ram the other way around, I just obviously flip the sheet over and it's no drama at all. This one's just a straight rectangle, I didn't need any cutouts for this. Just peel that off. Something nice and satisfying about brand new acrylic. And then that's going to go in there. And again, I'll get a couple of bungees or possibly some clips that I can tighten up just to make it a bit faster to take off. And this is thick enough that it should prevent anything from escaping from this when a sample goes. Typically travel kind of outwards, but that doesn't mean it won't ricochet and fly up. So once that's kind of strapped down, you've got a lovely clear window so you can really see what's going on, but nothing's going to fire through and hit you in the face. And that's pretty much it really. So we've got kind of everything assembled, rams in, need to attach the pump of course, need to go and set up with a computer so that we can see what's going on with the force generated here. So I will cut and do that now and come back and show you the first test shortly. Okay, well that's everything pretty much set up now. I've attached the hydraulic pump onto the pull ram. We've got our sample in. I've also added a small piece of cord between the 2 soft shackles just to further limit the range of bits flying when things do break. The laptop's hooked up to the load cell. That probably won't come out on the camera screen, just it's really bright out here, but I'm doing a screen capture on it now so I can show you the graph as that's generated. So the only thing I need to do now is to secure the final piece of acrylic over the sample, and then we can start pulling. Okay, so that's everything protected. Set the ram on. Here we go. This won't produce a really smooth graph because I'm applying the force kind of in incremental strokes, but it will be able to give us a peak. Putting some effort in now. Can't be far off. That carabiner is definitely changing shape. Ooh. And there we go. Ooh. Makes you jump. Ah, there we go. So 28.48 kilonewtons, which I've got to say is not at all shabby for a really ancient battered snapgate carabiner. Yeah, a successful first test. Everything worked. Nothing has broken, including me or the kit, so yeah, brilliant. Okay, so we're straight in with another sample now. I've got an old clog screw gate here rated to 30 kilonewtons. This time I've set the close-up camera for high speed, so we'll see how that works. It's changing shape again. And she's gone. So that one reached 34.35 kilonewtons, so despite the age of that carabiner, it was still quite a bit stronger than its rated braking strength. Well, everything seems to be working. There's a couple of little chips on the acrylic where the ram's jumped around, so I might need to add a little bit of extra padding in there. But the protection has worked. The load cell is talking nicely with the computer. The soft shackle system with a little backup cord seems to be working fine on there, and no problem at all with the hydraulics. So I think it's a successful test. So a couple of final tweaks to make, and then this is ready to go on the road and appear in future videos. Cool. Thank you for watching. Quick follow-up, I've just discovered what happens if you release the hydraulic couplings and you've not fully released the pressure off the ram. You get a spray of hydraulic fluid everywhere across your garden, water butts, face and clothing. So yeah, got that to clean up now.